All right, welcome to the Explainer. Today, we're tackling something that's absolutely crucial if you're managing complex data environments. You already know that authentication isn't just some box you check. It's literally the foundation of your system's integrity. So our goal today is to completely demystify the Entra ID integration process for Deephaven. We're going to break this down step by step so you can confidently deploy it in your own environments. If you're building data-intensive applications, you've definitely run into this massive security headache. How do you secure Deephaven for both humans and headless machines at the very same time? It's a fundamental challenge. You've got interactive user logins demanding multi-factor authentication on one side, and then automated, headless background scripts running 24/7 on the other. They completely collide. Building an architecture that gracefully handles both of these without compromising security is exactly what we're going to solve today.
Okay, let's dive into this. Here is our blueprint to give you a mental map of the architectural journey ahead. We'll hit Entra ID core terminology, setting up the server, the human flow with MFA, the server daemon credential flow, connecting those auth flows, and finally, enterprise scale with AD groups.
Let's get to it. Section 1, Entra ID core terminology. Think of Entra ID as the bouncer, and Deephaven is the exclusive club. Before that bouncer knows who to let in, you have to define the rules, right? That brings us to our very first core concept, app registration. Basically, this is the specific identity configuration inside Entra ID that defines exactly how a particular software component authenticates and what it represents. You can't just connect to Entra ID. You actually have to register your application's intent. This brilliantly illustrates how we don't just use one catch-all configuration. Instead, we split our identities into 3 completely distinct app registrations to handle entirely different authentication scenarios. First, Deephaven API acts as the resource or audience. That literally represents the Deephaven server itself. Next, Deephaven users acts as a public client, representing our human users accessing the web ID. And finally, Deephaven PubSub is our confidential client, dedicated strictly to our headless daemons and background scripts. Moving right along, Section 2, setting up the server and the Deephaven API config. To get this running, you'll walk through these exact steps logically in the Azure portal. First, you register Deephaven API. Next, expose the API and add the access as user scope. Then you create your exact app roles. Now pay really close attention here. Role names like Trader US, Trader EMA, DH Admin, and Writer are a strict contract. They are not just casual naming conventions. They are wired directly into your Python application code for entitlement enforcement. And lastly, you absolutely must force V2 access tokens in the application manifest to ensure the tokens carry the correct issuer format that the server expects. Section 3, Human Flow and MFA. Let's look at the public client setup. So for actual humans, we use what's called a public client. What does that mean here? Well, it's an application, like your web browser or a desktop app, that simply cannot securely store a secret. It relies totally on delegated user credentials and multi-factor authentication. We literally never, ever generate a client secret for human-facing web apps because browsers are inherently untrusted environments where secrets are essentially public knowledge. To build out this human-facing setup, you first register the Deephaven user's application, and again, completely without a secret. Then you add a single-page application, or SPA, platform type with your exact redirect URIs. Step 3 is a total deal-breaker. You have to toggle Allow Public Client Flows to Yes. If you miss this step, your device code logins will just fail with some super cryptic errors. Finally, grant delegated permission to that access as user scope we just created on the server registration. Let's see how this builds in real time for a user. The user navigates to the Deephaven IDE. Bam! They are instantly and automatically redirected to the Entra ID login page. The user completes their Microsoft Authenticator, MFA, natively within the Microsoft ecosystem. Entra then issues a token packed with the specific app roles assigned to that user. That token is seamlessly passed right back to the Deephaven IDE to grant access. The heavy lifting of identity verification, it's entirely handled by Entra. Which brings us to Section 4, Server Daemon Credential Flow. Let's configure our confidential clients. Now, what's really interesting about this setup is the stark contrast. On one side, humans use delegated access with MFA, but on the other side, machines demand a completely different approach. They operate as confidential clients that require a securely stored client secret. Entra ID strictly demands these distinct configurations to maintain tight security boundaries. I mean, machines obviously can't whip out a smartphone to approve an authenticator prompt, right?
Compressing the portal configuration for this confidential machine client, it takes 4 actionable steps. First, register the Deephaven Pub subclient. Second, generate and securely store a client secret. And hey, quick side note, never ever store this secret in your Git repository for the whole internet to find. Stick it in a secure vault or an environment variable. Third, add application permissions, not delegated permissions, for the writer role. Finally, an administrator absolutely must grant admin consent for the tenant so the daemon is authorized to act on its own behalf. Once that's locked in, this headless lifecycle runs beautifully. The daemon requests a token via MSAL, the Microsoft Authentication Library, using its client ID and secret. MSAL just natively handles the token cache and silent renewals in the background. Entra ID validates the credentials without any human MFA prompt. A token is issued containing that powerful writer application role, and boom, the daemon can continuously publish its data streams to Deephaven seamlessly, surviving long-running tasks way past token expiry.
All right, Section 5, connecting the auth flows for server-side validation. So the crucial point here is that the Deephaven server is not in the business of verifying passwords. It offloads all of that identity verification to Entra. When the server receives the JWT, the JSON Web Token, it simply validates the issuer and the audience to make sure the token is actually meant for it. It then extracts the object ID and those embedded roles claims. From there, it gates superuser access based purely on the presence of the DH-admin role, and it dynamically denies table fetches if the user's token is missing the required Entra-entitled roles. It's just clean, efficient, role-based enforcement.
And finally, Section 6, Enterprise Scale and AD Groups Mapping. This is where the architecture really shines for a DevOps team. You can take your existing Active Directory groups and natively map them to these exact app roles. For example, the AD group DHADM maps straight to the admin app role, giving them superuser access. DHRead maps to the reader role. Because these roles are just data passing through the system, Windows SSO and your existing AD groups plug right into this with absolutely zero code changes required on your end. The access requests just flow through your standard corporate IT channels. It's a real game changer. But I gotta share this vital enterprise caveat so your teams aren't caught off guard. First, assigning 80 groups to app roles requires an Entra ID P1 license. You won't find that on the free test tiers. And more importantly, group nesting is absolutely not expanded by Entra ID. Assignments apply to direct members only. So if you put a subgroup inside your DHRead group, those subgroup members are getting nothing. You really need to keep your 80 groups flat. Finally, as you scale this out across multiple engineering teams, please don't just share one master client secret. That's a disaster waiting to happen. Instead, register one confidential app per team or workload. This independently contains the secret blast radius. If one team leaks a secret, you only rotate theirs. It ensures true least privilege by granting only specific app roles, keeps your audit logs perfectly distinct per team, and allows for independent offboarding of projects without breaking everyone else's pipelines. And there you have it. The architecture is fully realized. You've got a rock-solid, distinct authentication flow for both your human analysts and your automated daemons, all centralized under Entra ID's powerful umbrella. So now that your human users and automated machines are perfectly secured, what massive data sets will your enterprise build next on Deephaven? Thanks for joining me on this explainer, and happy building!